Output for day 1, we're going to solve radical equations. So equations with radicals that have variables in their radicands are called radical equations. An example of a radical equation is 2 square root of x plus 1 equals 4. In order to solve radical equations, our first step is to isolate the radical on one side of the equation if necessary. Step 2, we're going to raise each side of the equation to the same exponent to eliminate the radical, and we'll obtain a linear, quadratic, or other polynomial equation. So linear is like a single x, for example, like 2x equals 5. And then quadratic has the x squared, and then trying to solve for that as well. Then we're going to solve the resulting equation using techniques you learned in previous chapters, and we want to check our solution. So let's try this example here, solving radical equations. So what we want to do is isolate the radical. So the radical is this here. So to do that, we want to first divide by 2. So we get square root of x plus 1 equals 2. Then in order to get rid of this square root, in this case, we're going to square both sides, so raise each side to the second power. Then we get x plus 1 equals 2 squared, which is 4. Subtract 1, so we get x equals 3. Then let's check. So we check by plugging in 3 into the original. 2 square root of 3 plus 1, does that equal 4? So we get 2 square root of 3 plus 1, which is 4. And then square root of 4 is 2, and remember that is multiplying, so you multiply them together, and you see that 4 equals 4, so this is true. Letter B, we have cube root of 2x minus 9, and then minus 1 equals 2. So we want to isolate the nth root, so we're going to add 1 to both sides. So you can't do anything inside of it, leave everything in the radical alone. So we get cube root of 2x minus 9 equals 3. Now the radical is isolated, so we can raise each side to the third power, and that cancels out that radical. Now we have 2x minus 9 equals 3 cubed. Remember, 3 cubed is 3 times 3 times 3. So therefore that is 27. Then we solve for x. To solve for x, you isolate the x. So 2x equals 36. Divide by 2, so x equals 18. Then we check. So cube root of 2 times 18 minus 9, and then minus 1, does that equal 2? So we're not trying to solve again, so leave the right side alone. We're trying to see if the left side is going to equal to that 2. So if cube root of 2 times 18, which is 36 minus 9, minus 1. 36 minus 9 is 27. And then cube root of 27 is 3. So 3 minus 1, does that equal 2? And yes, 2 equals 2. So x equals 18 is our solution. So try the next 3 problems. We have cube root of x minus 9 equals negative 6. And square root of x plus 25 equals 2. And then also this one at the top, 2 cube root of x minus 3 equals 4. So try those 3. I'll write this one down here so you can try it out. And then when you come back, I'll have the answer for you. So for number 1, you should have gotten x equals 27. You add 9 to both sides first. Cube both sides and you get x equals 27. And you plug it in to check. Then you square both sides here. The radical is already isolated. Then you subtract 25 from both sides. You get x equals negative 21. You plug it in and that works. 2 equals 2. So that is true. Then for the last one, you divide by 2 first. So you get cube root of x minus 3 cubed equals 2. And then you cube both sides. And you find that x minus 3 equals 8. And you find that x equals 11. Then you double check, and that is true. 4 equals 4, so that is correct. So next we want to solve an equation with an extraneous solution. So here we notice that our radical is already isolated. So what we need to do is what we've been doing before, is to square both sides of the equation. Now what's really important to note is on this left side you're squaring a binomial, and so we need to remember how to do that. So I'm going to put it on the left side, or on the right side, to do a little bit of work. So this is x plus 1 squared. Remember that means x plus 1 times x plus 1. So you can use either FOIL or the box method to multiply it out, or you can memorize, if you can use the pattern, a squared plus 2ab plus b squared. So however you want to do that multiplication there is what you should do on that. So it's x squared x, and 1. So this is x squared plus 2x plus 1. So this is x squared plus 2x plus 1. And then what's nice on this side, that square takes care of that square root, so 7x plus 15. So we have a quadratic, so what we need to do now is to set it equal to 0. So with quadratics, you set it equal to 0. It's helpful to keep the x squared positive. So we get x squared minus 5x minus 14 equals 0. Then we see if it's factorable. And we do see that negative 14, that does work. So negative 7 times a positive 2 is negative 5. So x minus 7, x plus 2 equals 0. And we see that x equals 7 and x equals negative 2. Then, of course, we need a check to see if we have any extraneous solutions. So we can do that on the right side. So now let's do a check. So I erased that on the right side. So let's see x equals 7 and x equals negative 2. And I want to test that in our original solution here. And so, or original equation, so not the one that's squared. So be careful with that. So let's plug in x equals 7. So 7 plus 1, does that equal the square root of 7 times 7 plus 15? Again, I'm plugging it into the original here. So 8, does that equal the square root of 49 plus 15? 8, does that equal 49 plus 15? That is 64. So square root of 64 is 8. And so 8, that is a solution, so I'm going to go ahead and box that. Now let's check negative 2. So negative 2 plus 1, does that equal the square root of 7 times negative 2 plus 15? Negative 2 plus 1 is negative 1, and then whatever's in the square root. So what I want you to notice, first of all, is that, number 1, this is a negative 1. Is there any way that we're going to get negative out of this radical? Now we can't. So we can kind of see already that this isn't going to work. This is an extraneous solution, but let's finish solving it to prove it. So 7 times negative 2 is a negative 14 plus 15. So negative 14 plus 15 is a positive 1. And then, so square root of 1 is a positive 1. And so negative 1 certainly does not equal 1. So therefore, negative 2 is an extraneous solution. So our only solution here is x equals 7. So now try this example here in your notebook. So square root of 10x plus 9 equals x plus 3. As a hint, when you get your quadratic, when you set it equal to 0, you are going to want to do GCF, and then don't forget zero product property. If you tried this out, you would have squared both sides, and then it becomes x squared plus 6x plus 9. Then it's a quadratic, so you set it equal to 0, move everything to the right, so subtract 10x minus 9. When you do that, you get 0 equals x squared minus 4x. Then, this is where I said, take the GCF. There's no constant, but we see that we have something in common we could factor out. We can factor out an x. So then when we do that, remember when you do that, you put it in the front. So x parentheses x minus 4, because remember if I multiply this back, I should get my x squared minus 4x back. So looking here, now it's already factored, and so we use the zero product property. And so when we do that, we see that x is 0, x minus 4 equals 0, and then, so this is x equals 0, and this one is x equals 4. Then, so these are our solutions, but we have to check to make sure that they work. So plug it into the original. So x equals 0, I plugged it into the square root of 10x plus 9 equals x plus 3. So 10 times 0 plus 9, and all under the square root. Does that equal 0 plus 3? And we find that that works. And the same thing when I plug in x equals 4. That does work as well.